Welcome to Chapter 14, the last chapter of Surviving Statistics. Hopefully you've made it through and you're doing just fine in your stats course if you're taking one. In this lesson, we're going to cover goodness of fit tests. We'll talk about equal expected frequencies and unequal expected frequencies. And good news is the chi-square that we're going to work with is very simple, very easy. So it's a good way to end this textbook. If you recall back to chapter 1, we talked about different scales of measurement. We talked about the ordinal, the interval, the nominal, and the ratio. We discussed that not every statistic could be computed from every scale. The nominal, for instance, we can't compute means or several other measurements, but we can, using the chi-square and goodness of fit tests, analyze frequencies or counts. And so in this chapter, we're going to compare the frequencies we actually have to what we expected to get. Our goodness of fit, equal expected frequencies, is going to use a fast food example. And some people love fast food and a lot of people hate fast food. Tina is one of those individuals that hates fast food. She can't stand it, and she's absolutely sure that everybody feels the same way as she does. In her mind, nobody in their right mind would have a preference over one bad fast food chain over another. So she sets out to prove that hypothesis. She's going to give 108 individuals a list of 4 fast food chains, and she's going to ask them to pick their favorite, and she's sure there will be no preference shown. So here are the results of Tina's fast food preference survey. Of the 108 individuals that she surveyed, 24 selected McDonald's, 25 selected Burger Queen, and 59 selected Chicken Deluxe. So now she's going to go through the 5-step hypothesis testing procedure to see whether or not there is an actual preference at a statistically significant level. All right, the null hypothesis in step 1 is that there is no difference in fast food preferences. The alternate is that there is a difference. Step number 2, the level of significance. Tina has selected a 0.05 level of significance, giving her a 5% chance of making a type 1 error. Determine the test statistic. The goodness of fit uses the chi-square distribution. Here you see a chi-square distribution table. The degrees of freedom for chi-square are k-1. In this case, there were 3 categories, 3 fast food vendors, so the degrees of freedom are 2. We locate the 0.05 right tail, and we end up with a critical value of 0.5991. The goodness of fit, or chi-square, requires that we compute expected frequencies. And in this case, we said that this was equal expected frequencies. We did not anticipate anybody having a preference. All 3 would be roughly distributed 1/3. So we compute the expected frequency being, in this case, 36 out of 108. Now, once we've done that, we're then able to go ahead and compute the chi-square. And the chi-square is the sum of the frequency observed minus the frequency expected squared divided by the frequency expected. And we'll do the computation on the next screen. All right, here we see the computations of the chi-square. We have the observed frequency. For instance, McDonald's, we observed 24. We expected, because an equal expected frequency, 36. So the difference between the frequency observed minus the frequency expected squared is 144. We divide that by the frequency expected, and we end up with 4. We sum that all together, and we end up with a chi-square of 22.056. Well, that is larger than the critical value, and so we must reject the null hypothesis. And so Tina's assumption that there was no preference in this case cannot really be asserted. All right, now we're going to run through a goodness of fit with unequal expected frequencies. In other words, we do not expect these all to be equal. So a recent study conducted by the Chicken Growers of America found that people prefer chicken sandwiches to burgers by a 2-to-1 ratio. Well, Tina is still sure that no one likes any kind of fast food, chicken or burgers, and so she sets out to prove them wrong. Now, we're going to assume for this case that only Chicken Deluxe serves chicken and that the other 2 only serve burgers. So going through the 5-step hypothesis testing procedure. Step 1, the null and the alternate. So the null is there's no difference between the results posted by the chicken growers and the results of Tina's survey. In other words, Tina's survey is going to assert a 2-to-1 preference over chicken. And the alternate hypothesis is that there is a difference between what Tina saw in her survey and what the chicken growers found on their research. All right, she continues on with her five-step hypothesis testing process. Step 2 is to select the level of significance. She's decided to go with a 0.02 level of significance this time, giving her only a 2% chance of making a type 1 error. And she is sure that selecting this level of significance will strengthen her campaign to stamp out fast food altogether. Step number 3, determine the test statistic. Well, again, it's a goodness of fit. Once again, it uses the chi-square distribution. Step number 4, determine the critical value. Well, we look up the chi-square table with the degrees of freedom of 2 and a 0.02 in the right tail. We end up with a critical value of 7.824. Right, step number 5 is to take a sample, compute the test statistic, and make a decision. Remember, this is unequal expected frequencies. We are expecting a 2-to-1 difference between those that preferred chicken and those that preferred burgers. So we compute the chi-square still the same. We take the frequency observed and subtract the frequency expected as shown there. But in this case, McDonald's, we observed 24, we expected 21.6. Going down to Chicken Deluxe, we observed 59, we expected 43.2. So we do the calculations, we sum up the differences squared divided by the frequency expected. We then end up with a chi-square of 6.582, and this is not larger than the critical value, so we do not reject it, the null hypothesis, and in this case, it appears that people do prefer chicken 2-to-1. Well, Tina can't reject the null hypothesis, and her research seems to agree with the chicken growers, so she's given up. She's decided she can't beat them, so she's going to go eat a chicken sandwich and see what the big deal is all about. Well, let's go over some of the highlights of this very short and easy chapter. Goodness of fit allows us to do hypothesis testing on nominal scale data, and we compare the actual observed to what we expected to observe, and the chi-square formula is very simple. We sum up the differences between the frequency observed and expected squared divided by the frequency expected. And remember, all of these lessons are based on my textbook, Surviving Statistics, which is available on Amazon. And do remember to check out my website for downloadable files, calculators, and other resources.